Hello, in this video we will cover functions. We will see how to define a function, calling a function, arguments and default arguments, args and quarks, return values, scope, and lambda functions. Now let's open a Jupyter notebook and start coding about functions. To define a function, we will use def keyword, and after that we need to write the name of the function. Let's say hello. After the name, we will put parentheses and put colons and get into this function. Let's print something with it. Say hello world. Okay, this is a very simple function that takes no arguments and prints this statement when you call it. Let's run this cell, and after that see calling a function. It is very simple. I will write say hello, the name of the function, and put the parentheses at the end. If I call this is going to execute the code in this function named say hello. Let's run this, and it printed the statement in here. Functions can accept arguments when you are calling them. Let's create a function with which you can greet someone and introduce yourself. I will write def again and say hello with the same name with the above one. Okay, now I will write two variables in those parentheses, and those will be the parameters. Your name, just the name of the variable, and my name. Okay, after that put the colon, and we are going to print something in here in a moment. And now I will call the function at the end, say hello, and parentheses at the end. When you define a function like this, when there are some parameters, you need to send arguments to there in the place of them. Let's say your name is equal to John and my name is equal to Joy. Okay, those are the arguments and they are used when you are calling the function, and those called the parameters and they are used when you are defining the function. They are basically the same, very similar, but the difference is that one is used, parameters are used when you are defining, and arguments are used when you are calling the function. Okay, let's write the print statement in here with an f string f hello, and I'm going to call your name in here to greet you. Your name, my name is, and let's call my name in here. Okay, so John will be your name and Joy will be my name because they are in the same order. And if I run this cell, I'm going to get this string, which is hello John, my name is Joy. Okay, now let's get to the default arguments. We can assign default values to those arguments. Let's see an example. Def, let's say greet is the name of the function, open parentheses, and the first parameter is name, and the second one is message. Okay, but this time I will write message is equal to hello, and this will be the default value of this message. Okay, after that I will print let's say f and start with the message. You can of course use them in any order you want in your function. Message, okay, comma, and name. Put the exclamation mark at the end and run the cell. As you see, nothing happened because we haven't called the function yet. So for a function to do something, you need to of course call it. Now let's call it with greet, and I'm going to write the name in here. I don't have to write the message because it has a default value. If I run this, I will get hello John. It used the default argument as hello. Okay, but even if you are using default arguments, you can assign a value to them. Let's write greet again, and as name I'll call John again, but as message this time I will write hi. Okay, if I run this time I will get hi John, because now I have put an argument in here in the place of this message, so it didn't use the default value, it used the value I delivered in here. Okay, now let's see args and quarks. Args and quarks actually arguments and keyword arguments, and they provide flexible ways to handle functions with variable numbers of arguments. They are useful when you don't know how many arguments will be in your function at the beginning exactly. And the important thing in here is that the number of asterisks at the beginning, if there is just one asterisk, this will accept any number of positional arguments, and inside the function, single asterisk args treated as a tuple. And if there are double asterisks, this will accept any number of keyword arguments, and they will be very similar to the default arguments that we define the value at the beginning. And inside the function, double asterisk quarks are treated as a dictionary. Okay, this may seem a little complicated. Now let's see some examples of them to understand them. Let's start with the single asterisk, which is args or arguments. I'm going to define a function as print args, and the parameter will be asterisks and args in here. You can write, by the way, anything you want in here. As I said, the important thing is the number of the asterisks. Okay, now in this function, I'm going to create a loop for arg in args. Okay, I will print this argument. Okay, here we didn't see any usage of it. Where is the flexibility, you can ask. Here we will understand why they are useful. I'm going to call this function as print args. Okay, and I will write 1, 2, 3. If I run this, I'm going to get the result. Okay, but after that you can also write some other numbers in here. You can change the number of the arguments that you put in here, and it will be adapted to the values you are delivering. It didn't expect a fixed list that it can take as an argument. You can write anything you want in here, and it is going to print all of them. It is going to use them as the arguments in this function. Okay, now let's see the keyword arguments. Def print quarks. This will be the name of the function, and after that I will put double asterisks and write quarks in here as well. In this function I will start a loop for key and value. Okay, in quarks dot items. As we said, they are going to be treated as a dictionary, so we can call that items method on them, and this will return key value pairs, and we are assigning them to those keys and values. Let's print those keys and values with a formatted string. Say key colon, after that the value. Very simple. Now I'm going to call this function print works, and let's say name is equal to George and age is equal to 29. They can be confused with the default arguments. The usage is very similar, but the difference is that in the default arguments we are writing those something equals to value, those key value pairs, while we are defining the function. Let's see, like this one. But in this case, in the keyword arguments, we are writing those key value pairs while we are calling the function. That is the difference. Let's run the cell, and we'll get name George and age 29. So the arguments we have written in here are used as a dictionary in this function because we are using keyword arguments. And this is the functionality. And also, as we did with the arguments in here, we can change the number of arguments that we write, and this function will be adapted according to what we wrote in here. Okay, let's say job is equal to teacher, and this will be adapted to it, and the output will be different, will be added. The job will be added in here. If I remove name from here and if I run this, we'll get just age and job. Okay, now let's see return values. Until this point we were defining and calling functions, but we were not getting anything out of them. Of course, they were executing some code, maybe printing some values to the console, but they were not returning anything. Let me show you an example what I mean by that. Let's say a is equal to, and I'm going to assign this function call to variable a. Okay, let's run this. This is the output we get from this print. And if I create another cell and call a in here and run this, I'm not going to get anything because this function is not returning anything. Now let me delete those cells and create a new one and show how to return values. I'm going to create two functions in here as def sum, and this will take two arguments as a and b, and this is going to return a plus b. Okay, this is how to return some value from a function. Okay, and I'm going to create another one. I will call this sum old, and this is going to just print the output. This will take a and b also, but it is going to print the result of a plus b. Okay, now let's create another cell. First, I'll call sum old. Okay, and I will write 3 and 7 as the arguments. Okay, if I run this, I'm going to get 10, and this is the result of this print function in this sum old function. Okay, now let's create some more cells in here. Now I'm going to define the value of the same function to variable c. And if I run this, I will also get 10 because here the print is executing. But if I call c in here, I'm not going to get anything because this is not returning anything. Now let's create another variable called d, and this will be sum 3 and 7 with this function that is returning the summation of those two values. If I run this, I'm not going to get anything because there is no print function. But if I call d in here and run this, I will get 10 because this function sum 3 and 7 returned the summation of them, and we have assigned its value to a variable d, and now d is holding the value of 10. Okay. We will see and understand this return keyword better in the exercises. Now I'm going to show you another usage of those functions. In the first case, we were printing some values. In the second case, we were returning some values from those functions. And in the third case, we are not going to print or return anything from those functions, but our functions will have a functionality. Now let's see an example. Let's create a list as my list, and this will be equal to 1, 2, 3, 4, and 5. I will also define a function as my function, and it's going to take any list, a list as the argument, and it will reverse it by calling the reverse method of lists at the end. Okay. As you see, this is not returning or printing anything, but it has a functionality to reverse a list. Okay, let's call this function my function and put my list in it. If I run this, I'm not going to see anything because it is not returning or printing anything. But if I call my list at the end, you will see that our list is reversed. Okay, now let's see scope. Scope is the region of the code where a variable is accessible. Now let's start with local scope and local variable. Local variable is defined within a function and it is accessible only within the scope of that function. Okay, let's see an example. Def function. I'm not going to write any arguments in here. And let's define a variable inside of this function and it will be equal to 5, let's say. If I call print x in here, and after that call this function and run this, I'm going to get 5 from this function. But if I call print x out of this function and run this, I'm going to get an error because x is defined in this function and it is not accessible also outside of this function. Let's comment this out, run this again, and see this one. Let's see an example of a nested function. I'm going to define function and inside of it again I will write x is equal to 5. After that, while I am still in this function, I will create another one called inner function. Okay, and inside of this inner function I am going to reach to x and print it. After that I will get out of this function, but I am still in this main function, and I will call the inner function. Inside of it, inner function. Okay, and at the end I will get out of everything, and with the same indentation of this function definition I'm going to call our main function. Let's run this cell and we will get 5 from here. What happened here is that this is an example of enclosing scope, uh, which means variables defined in the local scope of outer functions, or in other words enclosing functions, will be accessible from the inner functions of it. This is the case in here. We have reached accessed value from the inner function, which is defined as the local variable of its outer function in here. Okay, this is also an example of a next nested function, and how it is working is that when you call this function in here, it is going to execute this code block. First it will say x is equal to 5, and after that it will define this function, and at the end it will call this. When you call this, it is going to print x from here, and we will see it at the console. Okay, now let's see global scope. A global variable is defined outside of any function, and it is accessible from any part of the code, including within functions, unless it is shadowed by a local variable of the same name. Okay, now let's see an example of it. I'm going to define x is equal to 5, and after that I'm going to create a simple function, and it's going to print x. Okay, this is actually the same thing that we did until now in this course. This is a global variable because it is outside of any function. It is at the first indentation. Okay, now I'm going to call this function, and I will also call print x in here. Okay, if I run this, I'm going to get 5 from this function and another 5 from this print statement. What happened here is that x is equal to 5. We can reach it from inside the function because it's a global variable, and also we can directly print it because it is again a global variable. Okay, now let's see an example of this situation shadowed by a local variable of the same name. I'm going to write x is equal to 5 again, and I'm going to create the function, and in this function I will say x is equal to 2. After that I'm going to print x. Let's now take these two, copy and paste it in here. Okay, this is the same thing, but we have added x is equal to 2 inside of this function. And if I run this, the output will be different than this one because we are seeing 2 and 5 in this case. This function call will printed 2, and this print x call printed 5 in this case. Why is that? Because globally x is equal to 5. When you assign 2 to it inside of a function, it is going to use x is equal to 2, but just inside of this function. So this print statement will print x is equal to 2 with this function call. But if you call it if you call print outside of this function, it is going to use the global value, which is x is equal to 5, because this is not accessible from outside of this function. So x's value is not changed globally. It is just it is 2 for just inside of this function. Okay, now let's see global keyword. Global keyword is used to refer to a global variable inside of a function. Let's see how can we use it. The function, and inside of this I'm going to write global, let's say z this time. Okay, and after that z is equal to 5, and I'm going to print z. Okay, outside of this I'm going to call it, I'm going to call the function, and I will also print z separately in here. If I run this, I'm going to get 5 and 5. As you remember, we couldn't use this print statement for a variable defined inside of a function, but we are using this z keyword, and it is helping us to call it from this outside of this function, because now it is treated as a global variable. Let's see. Let's copy this and paste it in here, and I'm going to change this to t. Okay, z to t's. And after that, I'm going to comment this out and run this one more time, and we will get an error. Why is that? Because t is just a variable inside of this function now, and it is not accessible from here because we didn't use global keyword for this. Okay, let's delete this one, and let's see another example of it. I'm going to create another cell. Let's do this. Okay. This time I'm going to define the global variable first, and after that I will define the function, and inside of it, let's say global x, and x is equal to 2. Okay, let's print x inside of this function, and also call it at the end, and also print x separately outside of this function. This is very similar to this one, that we are changing x's value inside of this function, but it wouldn't accept print in this print statement x is equal to 2, so it printed 5 in this case. But if I run this, I'm going to see that both function and the print will give us an output of 2. Why is that? Because we are using a global keyword in here. So after this one, if you write x is equal to 2, it is going to change the global value of the x, and after that x is equal to 2 everywhere. Okay, now let's see lambda functions. Using lambda functions is a way to create one-line anonymous functions. They can have any number of arguments, but they should only have one expression inside of them. Let me show you an example on a normal function first. Def square. This is going to take the square of a number that we put inside of it and return it. Let's return x squared. Okay. If I call this function square and put 5 in it and run this, I will get 25. This is a normal function. Now I'm going to do the same thing with the lambda expression. First, I will write the name of the function, and I am going to assign the lambda expression to it. Let's write the lambda keyword first, and after that the expression, the argument will be x. And I will put a colon, and the expression will be x squared. This is saying that take this as an argument and return this expression. If I call square in here and put 4 in this time, if I run this, I will get 16, which is doing the same thing with this normal function. Okay, let's see another example. By the way, I want to point something out in here. I want you to remember something. If you are using a normal code editor, calling a function that is not printing anything will not show you the result in here. You need to print it. But we are using a Jupyter notebook, so it is going to show us the value of the last item that is called in this cell. Okay, now let's see another example. Add function. This will be the function's name. This time I'm going to take two arguments, x and y, and the expression will be x plus y. Okay, if I run this, writing those two values in here, and run this, I'm going to get 7. Okay. Lambda functions are very useful when you use them as anonymous functions in other functions. Let's see it with a custom higher order function. A higher order function means a function that is taking another function as an argument or returning another function. Let's see an example of it. Let's define function. Okay, this is going to take n as an argument, a number, and after that it is going to return a lambda function. Lambda x colon, and this lambda function will return x to the power of n. Okay, now since this is returning another function, this is a higher order function. Let's see how can we use it. I'm going to write another function name in here, and I'm going to assign the function we have defined with n is equal to 2 here. Okay. When you put 2 in here, n will be equal to 2, and this function will return another function which is this lambda, and it's going to take the square of a number. Actually, this is the equivalent of doing it like this. Square is equal to lambda x, and the expression will be x to the power of 2. Okay, those two are the same thing actually, but in this way we are doing it uh, using a higher order function. Okay, if I comment this out and run square with 5, this is going to take the square of 5, which is 25. Okay, in this case, when the number you write in here will be in the value of x. Okay, we'll take x's place, and n is already 2 in here, and when you put x is equal to 5, it is going to be 5 to the power of 2 in this case. Okay, let's see another example. This time I'm going to create a function that is taking the third power of a number, and with this example we will see how useful those lambda functions when they are used with higher order functions. Okay, now I will write the name of the function as third power. Okay, and this will be equal to just function 3. Okay, whatever number you write in here, it's going to be the power of x in this function. Okay, if you call third power and put 2 in it and run this, this is going to take the third power of 2, which is 8. Okay, in this case, n is equal to 3, so this function will return this one with n is equal to 3. So third power function will be a function that is taking the third power of a number. So when you put anything in it, x will be this one, so it will be x to the power of 3 when we call it in here. Okay, let's see one last example of it. I'm going to take the square root of a number this time. Okay, this is again will be function 0.5. Okay, when you take the 0.5 power of a number, it is going to be its squared. Okay, it's square root. Okay, let's call this square root and write 25 in here and run this. We will get 5 from here. Okay, as you see, this is very useful when you use with higher order functions. We can create different functions with different functionalities using this higher order function, which is returning a lambda expression. Okay, now let's see map function. Map function applies another function to each item in an iterable and returns an iterator. This iterator will be a map object, and we are going to at the end convert it to a list to use it in our code. Okay, now let's create a list of numbers in here and see the usage of map function. It is very useful. 1, 2, 3, 4, and 5. Okay, now I'm going to create another variable in here as squared numbers, and this will be equal to a map object. This will take two arguments. First one will be the lambda expression. I'm going to write it in a moment, lambda function. And the second one will be a list, which is going to be this numbers list. Okay, what is this map doing is that it is going to apply this lambda function to the all items in this list. Okay, 1, 2, 3, 4, 5. And it is going to return them in their changed form. Okay. Now let's write the expression that is going to be taking the squares of those numbers, x and x squared. Okay, so all the items in here will be x at beginning, and they will be returned as x squares. Let's call this one squared numbers. Okay, and I'm not going to get a list that I expect as I expect. I'm going to get a map object at a location of this one. Why is that? Because this is not returning a list directly. This is returning an iterator, a map object. So I need to convert it to a list. This is the common use case. I'm going to take it in parentheses and write list at the beginning. So I put this map function in a list function, And if I run this one more time, I'm going to get the list that I want and I can use it in my code now. Okay, this is the map function. Now we are going to see filter function, which is also very useful. This function constructs an iterator. This means returns a filter object from elements of an iterable for which a function returns true. This may seem a little confusing, but basically this is going to be used to eliminate some elements from a list. Okay, and we will understand it better when I write the code in here. Now, first I'm going to copy and paste a list in here from 1 to 10. Okay, now I want to filter this list, and at the end I want to get the list of just the even numbers in this list. Okay, let's create it even numbers. Okay, this will be done with a filter function. This will also take two arguments like this map function, and the first one will be the lambda function. Let's do it like this for now, and the second one will be the numbers list. Okay, and this lambda function should be a function that is returning true or false values, because when we apply this function to the numbers lists items one by one, if it returns true, the item will be in our final list, but if it returns false, the item will be eliminated from this list by using this filter function. Okay, to do this, the argument will be x, and the expression will be x modulus 2 equals 0. So this is going to check if the number is even, and it is going to return true if it is even. So the even numbers will be in our final list, but it will return false for odd numbers. This will be 1 equals to 0, and after that the odd numbers will be eliminated from this list. Okay, let's call it at the end even numbers and run this. I'm going to get a filter object this time, and I don't want this because I want a list. So we are going to do the same thing as we did in here. We will take this filter function into a list function, and if I run this one more time, I'm going to get the even numbers list at the end. So as you see, those map and filter functions very useful when they are used with a lambda function in them. Okay, this was all for functions.